Hello people, today we are going to learn about absolute value inequality. So let's see. When an equality contains an absolute value expression, it can be written as a compound inequality. The inequality with mod of x is less than 5 describes all real numbers whose distance from 0 is less than 5 units. What does this mean? This means on a number line from 0 the distance is 5 units, so distance is 5 units, meaning from on the both sides, on negative side as well as on the positive side. So since it does not say less than equal to, that means the 5 is not included. So that's why there is no dot. Whenever there is a dot, that means 5 is included. Whenever there is a circle, that means 5 is excluded. So the solution are all the numbers between minus 5 and 5, but not including minus 5 and 5. So mod of x less than 5 can be rewritten as x is such that x is greater than minus 5 and x is less than 5. So let's solve this one. This one is equal to mod of x is less than, whenever we take something from to the other side of inequality, the sign changes. So since this is minus 3, if we take it to the other side of inequality or equal to sign, the sign changes. So minus 3 is less than minus 1 plus 3. So minus 3 changes to plus 3 on the other side of inequality. So mod of x can be written as mod of x less than 2. 3 minus 1 is 2. And when we want to remove the x mod from the x, then what it will be, as we learned here, that mod x less than 2 means the x is 2 units from 0 on both sides of line number. That means x is greater than minus 2 and x is less than 2, and not including minus 2 and 2. Let's see on the number line to understand more. So here x is 2 units from 0 on both sides. So 2 units on minus side is minus 2, 2 units on positive side is plus 2. So x is between minus 2 and 2, not including minus 2 and 2. So we have circle here and here, not dot. So let's solve another one here. Mod of x minus 1. Whenever we want to remove x minus 1, then it will become x minus 1 is less than or equal to, I will write like this, less than or equal to 2, or x minus 1 is greater than or equal to minus 2. So whenever we open the mod, the sign first expression we write as it is without changing the sign, and the second expression we write with changing sign and also changing the inequalities to the opposite. So again we have to write by simplifying it. So x is less than equal to, when minus 1 goes to the other side of inequality, it becomes plus 1. So 2 plus 1 will be 3, and this should be and x is here, minus 1 goes to the other side of inequality, becomes plus 1. So minus 2 plus 1 is minus 1. So it's greater than equal to minus 1. So x is less than equal to 3, that means 3 is included. So on number line we have to put dot, and x is greater than equal to minus 1. That means it is greater than equal to minus 1. So dot here on the -1 because including -1 is the solution. So this is how we represent on the number line. So we can write the expression as x is such that -1 is less than equal to x is less than equal to 3. So this is how we will write the inequality, compound inequality. Let's do another example. 2 mod of x is less than equal to 6. So whenever we take the number to the other side of inequality, the positive number changes to negative, multiplication changes to division. So here 2 multiplied by x. If we take to the other side, it will become division. So x mod of x is less than equal to 6 divided by 2. Mod of x is less than equal to 3. This just means that x is again removing the mod, we can write x is less than equal to 3 for the positive, and x is greater than equal to -3, 3 units. So x is less than 3 and x is greater than -3. So it is 3 units apart from -3 to +3. X is such that -3 is less than equal to x is less than equal to 3. This is the solution in compound inequality. -3 to 3. Let's solve another example. Mod of x is, we'll take 14 to the other side. This is +14, so it will become -14. So less than x is greater than equal to 19 minus 14 is equal to 19 minus 14 is 5. Mod of x is greater than equal to 5. Now by this notation we have already learned that this means that x is 5 units from 0 on both sides of the number line. So we can again write x is greater than equal to 5 and x is less than equal to -5. Here it or will come because it does not have a common solution. It says x is either greater than equal to 5 or x is less than equal to -5. So it is including -5 and 5 but on the opposite side of number line. So the solution set will be starting from -5 including -5, the x is less than -5, and starting from 5, x is greater than -5. Yeah, greater than not minus, greater than 5. So this is the solution set for the expression. So let's see one word problems to understand more. A pediatrician recommends that the baby's bath water be 95 degree Fahrenheit, but it is acceptable for the temperature to vary from this amount by as much as 3 degree Fahrenheit. Write and solve the absolute inequality to find the range of acceptable temperature. So it says it varies by 3 degree Fahrenheit. That means again think of a number line. It varies by 3 degree means it can be 3 units from starting from 0 on both the sides. In this case from 95. So let's see the current, let's say the current temperature is T degree Fahrenheit, and it says that it should be it can vary for by 3 degree Fahrenheit. So current temperature is T minus the bath temperature which is recommended by pediatrician is 95. That means the current temperature minus 95 degree Fahrenheit should be between -3 and +3. So for varying thing, what we need to do? We need to write mod. That means mod of t in -5 should be less than 3, less than equal to 3. So again, if we remove the mod t minus 95, we can write less than equal to 3 and t minus 95 is greater than equal to -3. So whenever we remove the mod, first positive side of the inequality should be written as it is, and then the negative side should be written with the reverse of the inequality. So t minus 95 should be greater than equal to -3. So let's solve the expression. T is less than equal to 95 plus 3 is 98, and t should be greater than equal to, this is minus 95, so when it goes to the other side it becomes plus 95 minus 3 is 92. So temperature should be greater than equal to 92 or less than equal to 98. So solution set can be written in the form of compound inequality as 92 less than equal to t is less than equal to 98. This is our solution set, that the temperature of the baby's bath water should be between 92 to 98. If we want to plot on the number line, what we have to do is draw a line, number line, and this is 92 and this is 98. I hope it was 98. 92 and 98, and this was recommended by the pediatrician. 95, the pediatrician said that it can vary by 3 degrees. So 95, 94, 93, and here 96, 97. So 3 degrees, 1, 2, 3. So the solution set is including this. So we have to put dot here and dot here on the number line. Starting from 95, which is recommended, it can vary by 3 degrees. So 1, 2, 3 degrees on this side and 3 degrees on the other side. 3 units on both the sides is acceptable for baby's bath temperature. So this is how we have to write the solution and graph it. Let's see another word problem to understand more. So a dry chemical fire extinguisher should be pressurized to 125 psi, but it is acceptable for the pressure to differ from this value by at most by, again it says it is acceptable to differ from 75 psi. That means from 125 it is acceptable to vary by 75 on both sides. That means 75 less than 125 or 75 more than 125. So let's see, the current pressure is P and the recommended is 125, and since it says it varies on both sides, so we have to use mod to signify both negative and positive. Less than equal to 75. So this is how we write the inequality for the given thing. Again, as we solved above, we can write P minus 125 is less than equal to 75, or and P minus 125 is greater than equal to minus 75. Again we will solve this problem. Less than p is less than equal to 125 minus 75 is 50, and p is greater than equal to 125 when goes on this side. Sorry, here this is minus 125, so we have to add 125 to the 75 because this minus goes on the other side of inequality becomes plus. So 125 plus 75 makes 200, and here this is negative 125 goes on the other side of inequality, makes it positive. So 125 minus 75 makes it 50. So the pressure range acceptable is for the fire extinguisher is between P is such that 50 is less than equal to P is less than equal to 200. So this is how we will write the solution com compound inequality, and we can graph it similarly as we did in the past one. So, let's see some special cases. This is x plus 4 minus 5 is greater than minus 8. So we can write the same thing as x plus 4 mod of x plus 4 is greater than, when minus 5 goes on the other side becomes plus 5. So minus 8 plus 5 makes it minus 3. 5 minus 8 is minus 3. So x plus 4 is greater than minus 3. So this is true for any value of x, because we are adding 4 to the number to the x. That means any number, if whatever number you put here uh, is greater than minus 3. So absolute value expression are always non-negative, therefore this statement is true for all real numbers. So whenever this mod comes, that means absolute value. Absolute value of this number is always positive. So even if you put minus 1 here, it is 4 minus 1, a value of, no, let's see an example of x is equal to minus 10. So even if you put minus 10 here, 4 minus 10 is 4 minus 10 is minus 6. Minus 6 under mod, and the absolute value of minus 6 is 6, which is greater than minus 3. So absolute value of expression are always non-negative. So this statement is true for all the real numbers. So the solution set is x is such that x is true for all real numbers. Similarly here x minus 2 plus 9 is less than 7. So when you take 9 to the other side, 7 minus 2 is minus mod of x minus 2 is less than 9 taken to the other side becomes negative. 7 minus 9 is minus 2. This is not true because absolute value, as we understood in the past example, that absolute value of any expression is always positive. So this positive number cannot be less than a negative number. So absolute value expression are always non-negative. Therefore, this statement is false for all values of x, because this cannot be true. The absolute value is always positive. Whenever whatever number you put in place of x, it should come out as positive because of the mod sign. Mod sign signifies absolute value. So this expression is not true for all values of x. An absolute value represents a distance. Remember this is important. An absolute value represents a distance, and distance cannot be less than 0. So guys, I hope you got some idea on the absolute value inequality. So subscribe to my channel or come back to my channel for more videos on algebra or maths and other things. Thank you very much for watching. See you soon.